right, guys, we're going to head into our lessons. Today we're doing H.02, and this is your introduction to vectors. Now I want to remind you before you get going, take advantage of the pause and rewind functions of watching a video, because you're going to see I've pre-written a lot of stuff. You might want to pause, write till you catch up to where I am, and then you can continue on. All right, introduction to vectors. Now, let's talk about it in concept first. Speed and velocity, those are two very related but very distinct concepts. So let's see how they're related and how they're different. Now, if I talk about how the speed, it's how fast I'm going, okay? So speed is how fast you're going. You might say something like the car's going 30 miles an hour. Now, velocity, and if you remember from your science classes, is a little bit different. Velocity is both speed and direction. So when we talk about velocity, we might say the wind is blowing from the east at 15 miles per hour. So there's the direction and there's the magnitude, okay, the speed. So velocity is an example of a vector. Actually, it's a verbal example of a vector. We're going to get into the mathematics of vectors, and that's where we're headed. Okay. So here you can see there's a lot of words here. So if you need to, pause the video, write it down, and then get caught up. Vectors can be modeled on a coordinate plane by an arrow. The length of the arrow is the magnitude. So the length, the longer the arrow, the greater the magnitude. The shorter the arrow, the smaller the magnitude. And the direction that the arrow points is the direction of the vector. So what I've got here is I've got a simple XY plane, and we're going to show a vector on this. So get my writing utensils and stuff ready. If I just put my straight edge down here, draw an arrow. Okay, so right now it's just a line segment. So we have what we call the terminal end. We'll call that point A. And then there's the arrow end, and we'll call that B. So the length of this line is telling you the magnitude, and of course it's pointing in a direction. Okay, so a vector is defined by 2 points. By 2 points. And in this example, we have points A and B. So it's got a tail, and in this case that's A, and a head, and we're going to call that B. So think of it like a snake, if you will. The head of the snake, that's the direction the snake goes when it's crawling, okay? Now, there are a couple ways to, when we're writing about vectors, to write the vector. Generally, well, not generally, but often you see it with a pointed bracket and then AB. So tail always goes first, head goes second. Or sometimes you see it like this, AB with a single-headed arrow on the top. Now, just so you know, in our textbook, they use parentheses like this. And you can see why I don't prefer that, because it looks too much like a coordinate pair. But this is how the book does it. You won't find me doing it that way, but just know that if you're doing assignments out of the textbook, they're going to show vectors like that. Now, just your first concept to remember, two vectors with the same direction and magnitude are equivalent. All right, so if you see two vectors, they're the same length and they're pointing in the same direction, we call those equivalent. Let's just go back to magnitude for a second. Obviously, direction here is pretty obvious, but let's say this were a wind vector and each square was, say, 5 miles an hour. You could actually figure out the magnitude by counting the squares using Pythagorean theorem. And if each square were, say, 5 miles an hour, this might be 35 miles per hour in that direction. But don't worry, we're going to get into a lot more of that. Okay, so let's talk more about drawing vectors. If I can get this page out of the way. Okay, so drawing vectors. This is example Stanford. Okay, so I'm given 4 points. A is at 5, 1, B is at negative 2, 5, C is at 9, 2, and D is at negative 3, negative 5. And let's draw vector AB. All right, simple enough. Put point A at 5, 1. So there's point A. And B at negative 2, 5. Grab your straight edge. Connect them. So here's B. Okay, now you have to distinguish what's the head and what's the tail. A is the tail and B is the head. So the arrow goes down here. What you have now is vector A, B. Okay? The next one, let's draw vector CD. Okay, so let's plot C. C is at 9, 2, 2, 4, 6, 8, 9, 2. So there's point C. And D is at negative 3, negative 5. So there's D. Get out our straight edge. Just like that. Now, C is the tail and D is the head. So this is vector CD. All right, so you've drawn your first two vectors. Now, we can start doing all kinds of neat things with vector. I want you to imagine you're in a small plane and you're going east at 100 miles per hour, but you have a tailwind of 20 miles an hour. Well, now you're starting to add things together. You've got two vectors, the speed of the plane and the speed of the wind. So we can expand on this. And we can do things like, let's draw vector B, A plus B. Okay, well, my head is a combination of the 2 points A and B. So first thing I have to do is take point A at 5, 1 and add it to point B at negative 2, 5. So I'm going to add these. So A plus B, that's the point A plus B, is at 3, 6. Okay, so, oh, and this should be in parentheses too. I'm going to go plot the point A plus B. So that's 3, 2, 4, 6. So that is the point A plus B. And the tail is at just B, so that's right there. I've already plotted it. So this line with A plus B being the head is the vector B, comma, A plus B. Okay? That's simple enough. That's not going to confuse any of you. Let's do another example. So this is example SDSU. Given 2 points A at 5, 3 and B at 8, 7, find an equivalent vector to AB with the tail at the origin. All right. Well, there's a concept I need you to start getting familiar with, and that is known as the head minus the tail. All right? That's head minus tail. So let's write that down. Head minus tail. So that's minus. Not dash, minus. So I'm going to take well, tell you what, let's do. Let's draw the vector AB first, and we'll do it in red. So I've got 5, 3. So there's point A, and B is at 8, 7. 5, 6, 7, 8, 2, 4, 6, 7. There's B. Straight edge out. Okay, so there's the vector AB. What it's asking is draw an equivalent vector, so that same direction, same magnitude, with the tail at the origin. So that's going to be down here, okay? So here is the tail right there of my new vector. I just have to figure out where to draw it. Okay, so this head minus tail concept. I'm going to take the head, so that's a B. So that's the head. And that's at 8, 7. And the tail, which is at A, and that's 5, 3. I'm going to subtract them, and I get 3, 4. So just hold on to that for a second, okay? Now, let's just use some logic. I want the vector coming off the origin to be the same length and same direction. Well, think of this like the slope of a line. To go from A to B, I go over 3 and up 4. Over 3, up 4. So, look, I can just go over 3 and up 4. And there's the head of my new vector. Look at how these are the same, because I went over 3, up 4 here, over 3, up 4 there. Now, look at the head minus the tail. You see the numbers again? This number represents a run, and this number represents a rise. So it's almost like looking at slope, okay? And I'm going to put this like that because that actually becomes a vector component. It tells me what to do. It says go over 3 and up 4. All right? So that'll help you with a little bit. That's just an example of drawing equivalent vectors. Okay? We're going to build on this, trust me. All right. Now let's get to, well, I'll tell you what I'm going to do. I'm going to pause the video here.